Hello friends, we welcome you all to this session of network analysis, the first very basic session where we are discussing concepts of electricity, which is a very important topic as far as network analysis is concerned. And we'll start with very basic concepts which is very important for electricity, which is charge. So friends, you might have noted that whenever a silk cloth is rubbed with amber, then there develops a capacity in the amber that it can attract pieces of silk or fur. Okay, so about 600 BC, before Christ, that is nearly 2600 years back, it was discovered in Greece that when rubbed with a piece of silk or fur, amber becomes charged and starts to attract small pieces of thread in vicinity. At that time, atom was not discovered. Today, we know that the atom is composed of a positively charged nucleus surrounded by negatively charged electrons. Total charge of the nucleus is equal to the total charge of the electrons. As the electrons are negatively charged, when electrons are removed from a substance, it becomes positively charged. So on other hand, a substance with excess electrons, if a substance has some excess electrons, it becomes negatively charged. Now atom is composed of a positively charged nucleus. There will be a nucleus in the atom surrounded by negatively charged electrons. Overall, charge is a very important concept in electricity. The basic unit of charge is coulomb, and the electron has a charge of 1.6021 into 10 to the power minus 19 coulombs. This is a very important number, and you may remember it because in many of the concepts we will require this number. Now from this charge on the one electron, we can easily calculate that if 1 coulomb charge, how much electrons will be present in 1 coulomb charge. So it is 1 upon 1.6021 into 10 to the power minus 19. This charge on the electron is this much coulombs. So 1 coulomb will contain this many of electrons. How many? 6 into 6.24 into 10 to the power 18 electrons. This is also a very important number, and many times questions are being asked that how many electrons are there in 1 coulomb charge. Atom is composed of a positively charged nucleus. Atom is composed of positively charged nucleus surrounded by negatively charged electrons. Okay, so charge is a very important concept. Now coming to current, rate of change of charge is current, and we can represent it like dq upon dt. Here we have represented the current. So if q is in coulombs and t is in seconds, then current will be measured in amperes. Amperes is the unit of current, you all know. 1 coulomb charge when passes through a cross section in 1 second, the current measured will be 1 ampere. This is also very important to note that if 1 coulomb of charge is passing through a cross section in 1 second, the current measured will be 1 ampere. From here we can easily work out an important conclusion that 1 ampere corresponds to the motion of 1 upon 1.6021 into 10 to the power minus 19, that is 6.24 into 10 to the power 18 electrons through any cross section in 1 second. If through any cross section 6.24 into 10 to the power 18 electrons are passing through that cross section, then we call it that 1 ampere current has passed. Okay, now coming to the second concept, it's also very important, potential. We'll keep learning these concepts as far as our studies of network analysis is going on. Potential, unit of potential is volts, you all know, and 1 volt is the work or energy done to bring a unit positive charge from infinite to a particular point. If you are bringing one unit positive charge from infinite to that particular point, the work done in doing that will be equal to 1 volt. Okay, so voltage is equal to work done per unit charge. V is equal to W upon Q. If differential amount of charge is given in differential increase in energy dW, the potential is increased by dW upon dQ. This will be the increase in the potential. That's why we define potential as work done per unit charge or energy per unit charge. Power. We know that potential multiplied by current is power. This is a very important equation. We all know that power is equal to voltage into current. Now voltage, we have already learned that it is rate of change of work with respect to charge. Okay, and current we already know from above equation that this rate of change of charge is current. So from here, if we cancel out this dq and dq, then power will come to be rate of change of work per unit time. That is, time rate of change of energy is power, or work done per unit time is power. So if we write it in the integration fashion, then from minus infinite to t, if we integrate power then with respect to time, then it will be the work done. So friends, this was the basic concept of electricity. We have studied charge, current, power and potential. All the four concepts are very important as far as electricity is concerned, and electricity we will be utilizing in network analysis. So let us keep reviewing these concepts as and when you get time. Thank you. So please subscribe this channel. Thank you.